Jumping into our Azure Disk Encryption video here. This is going to be kind of the follow-up to BitLocker, and it's a transition from focusing on our on-prem BitLocker deployments to encrypting Azure virtual machines instead. But essentially, this is actually going to be the same product. It just wrapped in an Azure solution instead of using the OS-based BitLocker deployments. The reason that this is different, the reason they had to rebrand and create something unique for Azure VMs versus just being able to use the existing infrastructure for BitLocker, is if you think back to the methods for encrypting an on-prem server with BitLocker, that also requires that you specify, it requires either that you have a TPM and that you're using TPM with a optional pin or startup key, but requires TPM because then you have the TPM chip that can manage your encryption key for you. Otherwise, if you don't have TPM, you have to use either a password or a startup key because it needs some mechanism for the encryption key to be protected. If you're using an Azure VM, you don't have access to the virtual machine on startup. So there's no way, if you don't have a TPM, which Azure VMs don't by default, to be able to enter that password or startup key when the disk starts up. It's not available to you. The best you can do is see the startup screen if you have guest diagnostics configured, but there is no mechanism for it. So what Azure had to do then is create a custom method for it using Azure Disk Encryption, which allows you to use all the features of BitLocker but on an Azure VM. The exam objectives we're going to be covering for the next video is enabling storage encryption by using Azure Disk Encryption. Azure Disk Encryption and every mechanism you can think of, you could just have it correspond in your brain to using BitLocker in Azure. And then you want to go over an objective for managing disk encryption key for virtual machines in Azure. How you manage those keys, what think about. And then the way I've broken down the video, we're going to talk about BitLocker and Azure Key Vault because those go hand in hand. We're going to be talking about your different disk encryption options. That's what encryption is enabled out of the gate in Azure, and then what are the other options available to you? Because there's a few. We're going to go through what it looks like to enable Azure Disk Encryption, and then we're going to talk about actually managing the keys, how they tie into Key Vault, and protecting your encryption keys, maybe creating your own key encryption keys. Gets a little redundant with the terminology there, but those are the videos that we're going to cover or those are the topics we're going to be covering in this video. If you recall from the BitLocker video, we talked about how any form of encryption needs a key that's used to encrypt that data. And on-prem, you have your list of key protectors or different mechanisms that are used to protect that key. And then once you've validated the protector, it uses the key to access the encrypted data. Like I mentioned, Azure doesn't have that mechanism for protecting it, or it doesn't have access to those protectors that it would need. So instead, what Azure is doing to protect your key is it wraps or places your key in an Azure Key Vault, a separate PaaS service that's used for storing encryption keys or passwords or any other sort of sensitive authentication strings. So anytime you see reference to Azure Disk Encryption, part of the requirements that goes along with that is an Azure Key Vault. So we're going to look at standing up a key vault for the ADE instance that we're going to do here. And then, but first, before we do that, we're going to talk about our different types of encryptions that you get with Azure. Because Azure Disk Encryption is just one of them, it's good to be aware of what comes by default and what are other options for configuring it. So let's pull up a site here. This is a feature comparison table, but it kind of goes side by side with the different methods of encryption. So I'm not going to go over the table here other than kind of have it up, and I might call it a couple things. But the different types of encryption that are available for VMs in Azure are the default one, which is called server-side encryption. That's essentially encrypting the VM on the host, not the host itself. And this is the default mechanism that comes with encryption, or the default encryption method that comes with any VM that you spin up in Azure. I have that associated also with encryption at host and confidential disk encryption. Now, it's the same technology, but it's slightly different. Encryption at host is what you'll commonly see referenced as end-to-end encryption. Essentially, that's actually encrypting all of the data for that VM starting at the host level, and also includes encryption of data flows between compute and storage. Now, if you think about that, that's like if your processor or RAM is reading data and that's stored in virtual disks, all of that is encrypted. That is not what's happening with server-side disk encryption here, where you can see it's only encrypting data at rest. So your server-side encryption is your data at rest encryption. Your encryption at host is encrypting all data from end to end. And then one step beyond that is confidential disk encryption. Confidential disk encryption, apart from encryption at host, is one extra level. We'll scroll up a little bit because you see this binds the encryption key to the virtual machine's TPM and makes it only accessible to the VM, meaning the host itself doesn't have access to that key, and adds an extra layer of security then, because Azure itself in the data center won't have access to managing or accessing any of that data. The key is tied to TPM. This is going to be very similar to what's called server-side encryption with customer managed keys. That is the same product as server-side encryption, but rather than relying on Azure to manage the keys for you, you are supplying your own customer managed key in a key vault to encrypt that data, so that the Azure platform doesn't have access to that customer managed key. You're controlling it. So it's like server-side encryption, but with your own keys. So it's kind of like a controlled encryption method. It gives you a little bit more security over it. Now, server-side encryption with customer managed keys then is also very similar to Azure Disk Encryption, because Azure Disk Encryption, like we've mentioned, is using BitLocker and storing that BitLocker key in an Azure Key Vault that you control and you have access to. An important security feature to be aware of for Azure Key Vault is that nobody has access to the keys stored in Key Vault unless they're explicitly granted access. And this is a universal rule across Azure Key Vaults as a product. When you create one, even if you're the one that created the Key Vault, you don't have access to anything in the Key Vault unless you've explicitly granted yourself permission to do so. And that's by design. That's set up so that someone might be provisioning your infrastructure and they can create you the Key Vault, but you only want a VM to be able to manage that key, because users don't need access to it. Then you grant that VM permissions, it's the only one that can read it. Now, obviously, if you're doing platform administration and you're creating a Key Vault, you have permissions to assign yourself the roles needed to grant those keys or the access policies. But you're going to have an audit log of doing that, and that's Azure's method of providing security to those Key Vaults. So it's assumed that anything here that's storing data in a Key Vault is going to be safe and going to be ultimately controlled by you. And one great indicator of that is if we're looking at this feature comparison chart, and we look at what Microsoft Defender considers healthy or not healthy, this kind of gives you the tale of how this stuff works if you read between the lines. So, excuse bit of a coughing fit there. So if we're looking at server-side encryption, which is default, Microsoft Defender considers this unhealthy. It's still a form of encryption, but if you think of the fact that Azure creates the keys, it manages the keys, the platform has access to those keys, you don't have a lot of control over it. So Azure by default is saying that's not really a healthy status when it comes to encryption. If you go over to encryption at host, now this key is managing encrypting all data at rest starting at the host level, so there's nothing that can intercept that data between the compute and storage. If you think about Azure as a platform, your compute is always going to be independent of your storage, because your storage is done through virtual disks. So it's got to be separate from the compute environment. So if you're not encrypting that data in transit, it could potentially be an area of exposure. I think that's one of the main reasons this is healthy versus this being unhealthy. Now, you go to the next level. This is Azure Disk Encryption. This is the product we're talking about. It's using BitLocker. You're controlling those keys. You're storing them in your own key vault. It considers that healthy. And then at the utmost level, you've got your confidential disk encryption, which is encryption at host with a key that's tied to a TPM, so it's only accessible to that VM. That's considered not applicable because Defender for Cloud can't even read that. So that's kind of how I think about it, and that's a different feature comparison. I realize all this stuff can get very much in the weeds, and for the actual exam objectives that we've got, we don't need to know that, but I wanted to run through the different comparisons so you have an overview. So getting specifically focusing now on Azure Disk Encryption, let's pull up really quick a Microsoft document that talks about what you can't do with Azure Disk Encryption as far as like what restrictions are in place. And I'm not going to go through all of these, but this talks about Azure Disk Encryption doesn't work on some of these configurations, and it has things like using shared storage across machines because it's going to be a BitLocker key tied to a single one. You can't have resources that are accessible by multiple machines. You can't do things like an NFS share or DFS because those are shares that need to be accessible either to other things or those are shared that might be across multiple computers. So it's not going to be able to use the access key as tied to an individual one. That's kind of the main concept to think here is it's only really going to work for situations where a VM has complete control over its own data and isn't interfacing with another one. There are other things like ephemeral OS disks or iSCSI disks where the disks might be somewhere else other than the VM. Those aren't going to work. And there's also restrictions on the size of disks or the type of disks that are being used in Azure. So you're going to want to pay attention. You're probably going to want to know this just from a reference if you're getting ready for the exam. And then also it talks about how you can't really mix Azure Disk Encryption with some of the other encryption methods. So you can't use it if you're using server-side encryption with customer managed keys. You can't use it with encryption hosts or with encryption at host. I would also expect it's not going to work with confidential either. There's also says you can't do it the other way. If you've encrypted a VM with Azure Disk Encryption, you cannot go backwards and then encrypt that with server-side encryption. It's not going to work for that VM anymore. It says that right here. So that's some of the restrictions that we've got in place for this. So let's talk next about what it looks like to actually enable it because that's getting back to the objectives for Azure Disk Encryption. And fortunately, up to this point, it's been a little bit confusing comparing the different ones, but the actual process of enabling it is going to be pretty straightforward. Now, there are some requirements for enabling this as far as GPOs. Let me see if I can pull that up really quick because I don't have the link saved. Group policy requirements. Okay. If you're using group policy in your environment to manage BitLocker, those BitLocker policies will apply to virtual machines using Azure Disk Encryption because it's using the same technology. And because of that fact, you need to be careful about excluding Azure virtual machines from some GPO settings you might be using. Specifically, you cannot be enforcing the use of TPMs with GPO. And the reason why is Azure Disk Encryption cannot use TPM. So if you have GPOs that require it, it's going to break the ability to use Azure Disk Encryption. It's just not going to work. So you want to make sure those policies, it's excluded from any of those policies. You also have certain requirements about the key size. BitLocker policy on domain joined virtual machines with a custom group policy must include the following settings. You have to allow 256-bit recovery keys. And that's because the recovery keys that Azure uses by default are longer than the regular ones that are available. So you want to make sure that's specified in group policy to prevent non-compliance with the recovery key that Azure is going to attempt to configure your VM with. Now, once you have validated that your GPO settings are good, that's really the only thing you have to check. And from there, you can go to your different methods for deploying BitLocker. Now, you can see here the quick start tutorials have the different methods you can use for enabling this. You've got CLI, PowerShell, and Portal, and these are all basically the same. They're just commands that you can run to enable it. You specify the VM, specify the key vault, and run it. We're going to run through the Portal setup really quick just so we can see what it's going to take in. You can see the creation of the key vault and everything that goes with it. So this obviously has you going through the process of creating the VM. We don't need to do that. We've already got one. So let's spin over to the admin portal and look at our virtual machine here. All right, we are over in the Azure portal here, and we need two things to make this work. We need a VM, which we've already got, and we need a key vault. I'm going to go ahead and create the key vault first rather than creating it as part of the portal, just so you can kind of see the different mechanisms that go into it. So let's go ahead and do that really quick. Now I will call out, let's see, right here, if you're using HSM, which is, I don't recall the acronym exactly, that's an advanced feature, then you do have to use a Key Vault Premium. We're not using HSM, so we don't have to use a premium Key Vault. There are a lot of Key Vaults. All right. I don't normally do this from the portal, so it's weird to me to see the icon for these. We're going to do Key Vaults, Disk Encryption, Dev E1, East US, and we're going to keep it standard because we're not using an HSM. And for soft delete, I think purge protection has to be enabled by default for anything that stores keys, because you don't want to accidentally lose the key vault and then you don't have access to whatever was being encrypted with that key. So I'm going to set the purge protection to be enabled, and I'm going to drop this down to the minimum so I can delete this key vault after 7 days from the deleted key vault section. Next, we don't actually care about the permission model. I'm going to go with Azure role-based access control because I'm familiar with that, but we're not really going to go into what the difference is here. And the one thing we want to make sure we check when we're creating this is that we want to allow resource access from Azure Disk Encryption. This is basically like an independent, all three of these are basically like independent settings for permissions to this key vault. By default, nobody has access to a key vault. Even the person that created it has to go and manually specify his own permission to get those keys, which we're going to do so that we can see the key when it's created. But this allows VMs to access this key vault specifically for Azure Disk Encryption. So we want to make sure this box is checked. I don't really care about networking here because it's not going to last very long, and tags. So we will go ahead and create this key vault, and I will, it's been taking a while today, so I'll probably come back in a minute once this is spun up. Our key vault is now ready. Thank God for fast forward. Let's go back to our resource group here and our management P1 VM. Now to enable Azure Disk Encryption, once you have your key vault, all you have to do is go to disks on the left hand side here. You'll see your disk listed here. It's under additional settings, and this is where some of the other encryption settings are too. You see your encryption host settings there. And normally this is going to be none. All transparency, I tried this earlier and it failed because of something specific. I'm hoping we don't run into that issue again, but that's why it was set to OS and data disks. So I'm going to select that again. We're going to specify the key vault that I just created. And I have not created a key yet, so we'll go ahead and create a new one. Management P1 ADE. And the RSA key size here, I had selected 2048. I'm pretty sure that's why it failed the first time I created. So I'm going to go ahead and bump this up to a 4096 key size, and let's fingers crossed it works. I've heard it's something to do with server 2022 where it doesn't work with 2048, but let's go ahead and create that key. And then what's going to happen is it's going to create the key, and it automatically creates the first version of that key once the key has been created. So we don't have to worry about specifying the version here. And I will hit save. and then it's going to go ahead and deploy this key to the VM. Now you'll notice this is using a VM extension just like the Azure Monitor Agent extension from the Sentinel video. If you're not familiar with those, want more information on what they are, go back and watch the Log Analytics and Sentinel videos to get a recap of extension. This is going to take a little while. It might fail. This is where it failed last time, and it does cause the VM to reboot, though I didn't get a warning message that it would. So I will stop here and then I'll come back once this is complete and we'll take a look at what happened. All right, it looks like that bigger key size did work for Server 2022. So I didn't see anything in the documentation specifying what the key size has to be, but it never hurts to make it bigger assuming your OS supports it. In this case it worked and we are now encrypted. I also will say if I switch over to my RDP session here, the server did not reboot. So it looks like encryption works with no server reboot. I have seen references in the documentation that you will be prompted. I think it was in the quick start guides for these that you will be prompted for a server reboot if you enable encryption. In this case, you didn't, so I don't know if that's something that's changed or if it only depends on certain circumstances. Either way, if you're doing this in a broad deployment, you might just want to consider that you may have to plan for a reboot to finish encryption. If we switch back to Edge so I can see my deployment here, let's go ahead and look back at the settings for that VM. So if I go to Management and I go to Disks and Encryption, right there, it says server-side encryption with a platform managed key and Azure Disk Encryption. So it looks like we are good to go. I also believe if I go to Defender for Cloud, I don't know, it takes a while for this portal to load, so this might not work. If I go to this VM, yeah, I don't think this is going to work because it also doesn't show we have the monitoring agent when we actually do. So, bad example there. But that's all there is to enabling encryption for a Windows VM. And fortunately, for Linux VMs, it's basically exactly the same. Now, let's pull up. This is the quick start guide we've got for Windows, but you'll notice under Azure Disk Encryption for this documentation, there's Linux and there's Windows. So you can do the same. And if you go to the quick starts guides for Linux, tongue is tripping over myself here a little bit. You have the same options available under Linux as you do under Windows. CLI, PowerShell, or Portal. And the same instructions also apply. So this is creating the VM. This is going to your additional settings under data disks, choosing your key vault, making sure the access policy is set, creating the key vault, and you are off and running. So Linux and Windows is basically exactly the same. There is one requirement that I found though that you're going to want to be aware of, and that is Azure Disk Encryption does not work with every version of Linux. If I pull up this page here, which I will link in the video description, there are quite a few distributions of Linux if you're not familiar. This is kind of a cheap graphic on Azure that talks about it. You've got all your Linux versions here. You have some that are endorsed and available on the Azure platform, and then you have a smaller amount of that that's enabled for ADE. And they have listed every Linux version that does support ADE, but it does not have a lot of them. It's got CentOS, it has Ubuntu, so it's got some of the big ones, but it doesn't have like Debian, which I think is the AWS distro of Linux. I'm not a super huge Linux person, so I don't know. But you do want to make sure that if you're trying to roll out Azure Disk Encryption on a Linux VM, it's the same methods, but you need to want to make sure your distro is supported. Last but not least, let's go look at the keys that are available in our key vault. So if I go back to my portal and I pull up the key vault, if you remember, when you create a key vault, the owner by default does not have permissions unless they grant themselves permission to see it. So I'm not going to be able to see this, though my VM does have access to it to encrypt itself. I'm going to go ahead and grant myself a role so I can look at that key and validate that it's here. All right, I have been configured as the Key Vault administrator, and now if I go to keys, you'll see we have our key version listed here. There's a couple of features that come with Key Vault that I'll need to look up the documentation for real quick, and I'll probably do some video cuts here as I go from page to page. But by default, Key Vault does, in some circumstance, support auto rotation of keys. So if you want to not have the same permanent key constantly, you can set up Key Vault to automatically rotate it with a new version, in which case you'll see the versions increment here. You can specify how long that'll last or how frequently it rotates, and then that'll be good to go. The other mechanism that you've got, which Server 2022 does not support as the last time I checked documentation, is you do have the ability to use what's called key encryption key. So this document, Key Vault for Azure Disk Encryption, goes over the tools you need to create the Key Vault and the settings. We've already done this. We kind of already reviewed this. It has the CLI and PowerShell commands to it if you need it. You should probably know those if you're taking the exam, though they oftentimes are pretty straightforward. And then this is some of the access policies that we know we had to set. So enable Key Vault for disk encryption. That's that checkbox we set when we created the account. Enable Key Vault for deployment. If you are deploying your VMs and encrypting at the same time, you're going to need to do that additional level of setting. That's another checkbox that's in the same spot. And this is going to be the same thing. And here are those settings in the portal. So it talks about here's the auto rotation policies. It does say it has key auto rotation. It isn't currently compatible with AD. So we cannot use the disk encryption rotation feature, though. Yeah, it says it'll continue to use the original key. Now, if you remember, going back to this Key Vault, you've got the current version. This is the first version the key was created at. These versions are going to be retained. So if you try to use auto rotation, what this document is saying is it's always just going to use the original version of the key, and it's not supported. The other thing we can do here is what's called a key encryption key. This is going to be a bit of inception and gets a little confusing, but it is a security feature to be aware of. If you're using key encryption key, so the key that you create, the key that we have here that's used to encrypt our management P1 VM, this is encrypting the drives, the OS drives and the data drives that's on this VM. If I use a key encryption key, what that's doing is it creates a second key that you usually create beforehand. You usually have one of these for all of your VMs. And then that first key that you create is going to be used to encrypt the keys for each VM. So in this case, we would have a key encryption key, and that key would be encrypting a key for management P1. It would also, if we were going to encrypt with other servers, I have ADP1. It would encrypt that key as well. So essentially, it's a key to encrypt your other key values, which are sensitive, so that they don't get compromised. Like I said, it's a bit of inception, but it is a value you want to be aware of, or an option. And all it does is integrate with Key Vault. So you'll notice in your deployment settings, it talks about some of the requirements for encrypting with a key encrypted key. You just want to be aware that if that's the case, you create the key in the same Key Vault you're using to manage your other keys. And as a requirement for all this stuff, your Key Vault and your VM have to be in the same subscription and the same region as each other in order for them to work in Azure. Azure, you can have multiple subscriptions, and you can create resources in a subscription or resource group in multiple different regions. So I could create the Key Vault in North Central US and have my VM in West US, and that wouldn't work in this case because the Key Vault and the key have to be in the same region and the same subscription. Just a requirement I want to throw out there. I'm not going to go through the process of setting up a key encrypted key because it's pretty straightforward. You just essentially specify that when you're creating the resource, and then use CLI or the PowerShell command list to do it. But I wanted to explain what it is, so if you see references, you understand it. And that, in a nutshell, is Azure Disk Encryption. It's pretty easy and it's pretty transparent, very similar to when you're actually rolling out BitLocker to your endpoints in a big deployment. For the most part, it's transparent to users, and it's a pretty transparent thing because everything manages itself, but you have absolute ownership over the key itself because it's stored in your Key Vault, so the platform itself doesn't have access to it.